Good.
So, what I'm doing, should I go up here? I'll go up here then. Alright, so I'm going to present today on a special case SQL injection. SQL injection is basically the injection of commands into a SQL database which are not supposed to be there. I'd say it's defined by somebody being able to execute commands on a server that are not supposed to be authorized. So you're going to get a little, not a demo, what I'm going to do is describe the scenario that I came by where this SQLi came into being. So I'll describe the environment that was running on this website, which I accessed using a network of the VTCs. Alright, so all the scripts on this website are ASP.NET scripts, .ASPX. So all the programming was done with these scripts, at least the ones that I could tell. So I was kind of familiar with that because I'm more a PHP guy, but basically it operates on the same principles. It's going to take the GET request or the POST request, and it's going to try and escape that to make sure that it's not SQL injection, and then it's going to pass it into the database and get back results. So it was pretty difficult to kind of pin down a attack vector of this target because every single script had basically one purpose and it expected to get one GET variable. So you only send it the GET variable, which was an ID number. ID number was just a reference. So I couldn't send it a string, which would be command strings. I couldn't send it anything except for a number. So what it expected was to get back a number, which is why this is kind of a special case of SQL injection where you might, on a chance, have the possibility of sending back an entire SQL command, having to process on that and return it back. Okay, so, yeah, look at this changed. Master textiles.
It just put a text block on top of it.
Yeah, it did.
Just roll.
Whatever, I'm rolling with it.
Yeah.
Alright, so this is basically domain.com was the name of the domain that I tested, obviously. Directory script.aspx, and the GET variable I was looking for is ID. I looked for ID, which was a reference to a number like I told you before, and basically I had to redact all the information so you wouldn't know which website was vulnerable here because I'll hopefully take care of having them patch the vulnerability and it won't get exploited. So the first thing that I did was test the regular SQL syntax. The ID equals 21 and 1 equals 1. So if you want to imagine where this would be when the SQL statement is executed on the web server, it would look something like this. It would be select, and then you would have the name of the columns you wished. So it could be, we'll just say star for now, to select all columns from. And then you have your table name, which is right now unknown. This is a continuation going on here. You say the where clause to specify basically conditional. And in this scenario, we're guessing it's saying where some sort of ID is equal to, we tried 21. And that's what we basically think is going on back here in the back end of this ASP.NET script. We append onto that, and 1 equals 1, which is obviously conditionally Boolean true, and we would expect to see the same exact behavior if SQL injection was possible that you get without this than you get with it, because as far as the database is concerned, this is still a true statement. So the first step is to try that, and then the next step is to try and do 1 equals 0. And if 1 equals 0 does not display the same as before, you basically know that you're getting two different results for two different queries, and they're expected, so you can say, okay, there's some form of SQL injection here. Next, you have to basically figure out how you're going to pass information back to the database and get information back from it. So we know we can pass information through the GET request, but the way that we get information back from this is considered blind, because we're not specifically getting information from the database to be displayed back on screen. All we're able to do is check a Boolean truth, whether or not this statement is true. If it is true, we'll get the article displayed. If it's not true, we'll get it not displayed. And for that, this is called blind SQL injection. Okay, so something to note here. Not possible to modify which database columns are returned to the calling script. So that means we're not able to say we wanted to return back the password, username, and all this other stuff. Like I said, it's blind. It's only possible to verify the Boolean truth. Next thing I had to do, identify the tables. The slide got fucked up again. But to do the table identification, basically you had to brute force this, and I had to guess the name of what a table might be in this database. So obviously you go through a few things and you say, all right, first I want to see what is definitely not a table. I want to see the kind of response that I get from the server when I give it a table name that's definitely not true. So I said, select count from not table, because who would name a table not table? So I use that kind of as my test. And then you can see we get this lovely error message, which tells us Microsoft Access Database server cannot find input table query not table. So we know it doesn't exist. And then you have the harder part is guessing what does exist. Thankfully in my case, users happen to be a table name. So I mean it's good for organization. So if you want to keep your data organized in your database and have it easily read when you're managing it, it's great to say, okay, it's users, which means a table of users. But from a security standpoint, that's bad if you have SQL injection, because that makes it easier for me to guess. So obviously I said, yes.
Would you be able to say users and then just put, if you just had 2 or 3 random characters on the end, nobody would be able to guess it. Because at that point you have to guess it manually. You could use brute force, but when you're using it, how much of a pain in the butt is that going to be?
To use it? Not very much. You would just have to usually be included in a configuration file. And that configuration file would say the database name is users xkmg. And then you would just include that variable in the rest of your programs. So it's not definitely out of the question. It's just OCD for some people. They don't like it.
Okay.
There's another method for guessing table names, which involves an information schema. It's kind of a special case table, which would tell you a little bit more information about the general database law tables. But that's very rarely accessed, very rarely possible to get to. And thankfully, in my case, I didn't have to get to that. So we discovered table users. So I said, yeah, error messages are awesome. The thing about the error messages didn't give me a table name or any sensitive information. Really just said, all I know is that this table doesn't exist. Then we had to verify the other one to exist by verifying the users table. Next thing I had to do. So I'll kind of update things as we go here and show you a little bit how SQL tables and databases are laid out, so we can know exactly how we're trying to interact with this magic box behind there. So you have a database name. And databases have separate tables in them. So you can say this is, obviously we know table users exists, so we know there's now a table called users. Next thing we have to do is identify all the different columns. A column you can think of, if you know programming, as a variable. So you could say, okay, the variable, it's a variable name, and the variable name has a value. So the column name would be, in this example, we're going to guess user ID is a column name. So we say user ID, and then we have all these different variable names. And these each have their own record below that. So user ID could guess 1, 2, 3, and that's kind of how you can imagine it being laid out. So back over to our slide here, we are doing, basically we're testing again a Boolean truth. We're testing whether or not this statement is true. If it is, we'll see the article displayed back. And if the article is displayed back to us, we know that there is some column referenced as user ID in the table of users. Not only that, we know there's a user ID which is equal to 1. So we know this record over here, user ID in 1 in the table of users actually exists because the article has been displayed. Yes?
Select 1 will always return 1.
Yes, and that is a key that I use there. Select 1, it will always return 1, but the actual statement itself will be void if the second part, where, is false. Yes, Ben?
Is this the equivalent of using an Excel spreadsheet? That's the tab on the bottom. I don't know exactly what that's called. Users is a book.
It's a worksheet.
Worksheets, that's what they're called.
Yeah, you can think of it that way. And it's actually important to note that I always selected 1 because the way the IDs worked here, IDs only went up to, in the database I figured out there was only ID up to valid like 30 or something like that. So I had to make sure whatever was returned to the script was within 1 to 30. And I knew exactly what article 1 looked like because it always printed out article 1. So I would always have it select 1. 1 would be returned, and that 1 would be returned if a conditional Boolean calculation was true. So next we have to look for some more fields. Why not guess username? Makes sense. They call their table users. There was a user ID. Let's say username. You have to follow kind of the same naming schemes here. So we say select. This is a SQL function length. username, so it's going to give us the length of the actual value that is within username in that table from users where USRD equals 1, so we can update our table over here to now know that not only do we have a user ID, we have a username. And we don't know what the length is yet, but we'll update that later.
The fact.
It doesn't matter.
Alright, so we're password equals 8. We're password equals 6. Alright,
Just
we're back.
put a box in it.
And we're back.
I mean, yeah, there's just still a text there, but whatever. Alright, so we also figured out password length equals 6. And this is quite interesting because anything that's encrypted really isn't going to be past 6, or anything that's hashed. Anything at all, it's going to be more than 6 characters long. So we can kind of guess right now that not only is it easy to guess, but it's probably unencrypted, which is pretty big shit. So we're going forward. We verified 8 characters long, 6 characters long, mostly not encrypted. So, awesome. Now we know how long it is, we know a little bit about the system, we know how to execute SQL commands on the server. Let's try and get stuff extracted from the database. Problems. The ASP script only accepts integers, so we can't return it back the entire password string. We can't even return it back a character. Web page will never display anything beyond the article content. It's never going to actually display anything for the database back to us. Only a page if the ID actually even exists, and the SQL statement is true. And there's actually a SQL function, or kind of you would say, method called into-out file, where you can basically take a query and say you want the results of this to go into out file, name the file name. That's been disabled, obviously, because it's a pretty big security risk usually. Solution. So I was thinking, let's take the username. We use a function built in SQL called ASCII, converted to decimal, pass that back to the script, and then we will see a web page represented back that's a decimal representation of the first character of the password. So we're going to use the method called substring to get only one character of the username, and then we're going to turn it into ASCII, and we're going to subtract this from 64 because we know that's the ASCII table starts. More problems. SQL Server has been configured to forbid basically all functions that allow data type conversion. So this thing was locked down really, really well, with the exception of that one small SQL injection vulnerability right there. And it also does not support substring. Fuck. Sneaky fucking solutions. Only after many failures. That must be noted. So basically, there's something called left and right. If you use left, it'll return the first character of the string. If you use right, it'll return the last character of the string all the way to the right. Interesting enough, if you put right, left, string, and then the 2 parameters, you can create your own substring. So this number at 1 is the number of characters to read in at a time, because that's the numbers to read in from the left starting index, and number 2 is the index of where you're on the characters. So we solved our substring there. This is great. And now instead of integer conversion, we have this other solution, which is called in. In is another kind of tricky SQL thing that's not really used for something mostly, but it was there. It was available. So in is an array. So it creates a little array, and then you do an array of things to match. So I'll show you a little syntax we'll have right here. So we'll say, select from users where, and then if we wanted to have this boolean true, we could say 1 in 1. And basically it says where this conditional is inside of any of the elements inside of here. So we can fill this array and it's automatically going to search for this variable inside of here. So this works. It comes out to be pretty ugly and it takes some time, but what you end up doing is selecting one character at a time and searching through the entire alphabet in the function, and then you basically take that. If you say, okay, you have the entire alphabet A through Z, you know it's somewhere in there, chop the alphabet in half. And then if you know it's somewhere in there, chop it in half again. If it's not in there, go back a step. And
It's in
it's
the other half.
all manual labor. It's the other half. It's all manual labor, but it's all kind of Boolean stuff. So you think about it, it's logical if you go through it this way. So it takes a long time, but basically it comes down to looking like I went back one. Sorry, looking like that. So I have the entire alphabet listed through. Surprisingly enough, this guy's entire username has no special characters or numbers in it. That was also very helpful. So we have the entire alphabet, articles displayed, because we know in this case, we're reading the second character of the username is somewhere within these values. And then we figured out it eventually needed R. So the second character of the username is R. Because we've narrowed it down to one character being in an array of only one character. So it must be that character, logically. And we still see the article, so that expression must be true. Alright, so eventually we get to the point where we go all the way through the username, all the way through the password, and extraction complete. You would see, if I didn't redact it, the characters there that were the actual ones you could see. C and J, and that's all left in there. But that did take a lot of time because you have to go through the alphabet for each one. I would have loved to write a script for it, and eventually I'll probably do that. And also, you don't have to notice the lack of password encryption because you can't see it. But there's no encryption on the 6-character password. So from this, I have a username and a password to a user ID, which is 1, most likely admin. So all I have to do is find the admin panel. I found the admin panel. Log into the admin panel. You're at the admin panel. You get to manage admin users, redacted all information about admin users. You can do anything, and basically give you a scope of how much of a problem this is. This is maybe 1/20%, like 1/20th of their financial records for a year. We're talking slightly under $1 trillion worth of financial information here, and they have a SQL injection vulnerability, which was able to be found to be vulnerable in about 4 hours. I think maybe it did in about 2 hours total. But this is a pretty serious problem, and it should definitely kind of... I wouldn't put this on here if it's not meant to kind of put into your head how bad this can really get. Because you can just take that one problem, just having only the possibility of returning an integer, and then if you return always one integer and you get these Boolean expressions, you can verify these things. It gets a little tricky, but eventually you can break it into a username and a password, and from there, bad things can happen if you don't otherwise report them. And that is my presentation.